Guys, we have couple more concepts to learn, and then we're finished with electronic configuration. What we're going to do right now is look at the electronic configuration for bromine. That's this element right here. So we do all the stuff that we've done before. We start at the beginning of the period. So the first thing we have here is 1. We're in our S block. Hydrogen is in the S block. Helium is in the S block. We count 2 boxes, 1, 2. So you have 1s2. Go down to our next level. We have 2 in the S block. We have 2s, 1, 2. We have 2 boxes. We continue across. We're still on period 2, so we write down our 2. We're in the P block elements, so we write P. Count our boxes. 1, 2, 3, 4, 5, 6. We write our 6. We go down to our third level. We have 3. We're in the S block element, so we write S. We count our boxes. 1, 2, 2. We go across. We're still in the third level, so we write 3. We're in our S block element, so we write S. We're in our P block element, so we write P. We count the number of boxes, 1, 2, 3, 4, 5, 6, so that's 6. We go down to our fourth level, we write 4. We're in our S block elements, so we write S. We count the number of boxes, which is 2, 1, 2. We count 2. Now, when we get into our D block elements, the level drops by 1. So we're here at 4, but when we're in the D block elements, we have to write a 3. And we're in the D block elements, and we count the number of boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we write 3D10. Now when we continue across in our 4, now we continue across, now we're out of the D block elements. We're back in the main group elements. So because we're back in the main group elements, this becomes a 4. We're in the P block elements, so we write our P, and then we count the number of boxes. 1, 2, 3, 4, 5. 5. Okay? So when we're doing the electronic configuration, the important thing to get from this is that when you come out of your D block elements, whatever period you're on, it goes back up. So we have 4s2. When we're in our D block elements, it drops down to 3D. Count the number of boxes, which is 10. And then when we come back into our P block elements, it goes back up to 4. So that's 4P, 1, 2, 3, 4, 5. And that's what we have here. So one of the things that you will find is that this will be rewritten to put all the 3 levels together. So when you're doing your test, you might see all the 3s are together, and it might confuse you. So you can rewrite this to be 1s2, 2s. What's wrong with my pen? 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p5. When you take your exam, you're going to hear something called ground level. ground level or ground state, which means just the lowest energy state. So what you're learning right here shows you the ground state of an element. When we look at excited state, we're saying that the elements or the electrons are found in different orbitals because the atom is excited. All right, let's try one more. Look at this one here. We have determine the electronic configuration of molybdenum, MO. Let's see. Make sure my pen is on. All right, now look, I'm going to show you something here that's going to save you a little bit of time, and you're also going to see it on your exam. We can do this in a shorthand configuration. So with the shorthand configuration, instead of me writing out the whole thing, 1s2, 2s2, going through the whole thing, I can write the noble gas element that precedes the row and then continue. So in this instance, we're looking at BMO, which is here. So if I look at the row ahead of it, the row ahead of it is 4. So I can write krypton. So I can go K, R, in parentheses. And then continue to write the electronic configuration. So I'm in group 5. So I can write 5s2. I'm going across. I'm in the D block elements now, so it has to drop 1. This is called 4D, and then I count the number of elements. 1, 2, 3, 4. Now, what I've just done is showed you the shorthand method of writing the electronic configuration. Instead of writing 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, all of that is represented by KR, which is written right here. So what you're seeing here is the shorthand method of writing the electronic configuration. You can use the element in the noble gases only that precedes the row that you're looking for. So if I wanted to write the electronic configuration, say for calcium, I could just look at the element ahead of it, noble gas before of it, which is argon, and then I would simply write argon in parentheses. I would have AR in parentheses, and then I would write 4s1 for the electronic configuration of calcium. All right, I think that's it. If there's any questions, just give me a call.